Let's take a look at one more example. Let's go back to the BCA GitHub file page here and let's stick with the California theme. How about this California housing.csv? Let's look at this one. View raw. And this looks good from the outset because there's quite a few numeric columns. So, but it's always best to look at it in the Colab notebook. So here we go. Open up a new URL. And then go ahead and do df equals pd.read underscore CSV. Get the URL in there and df.head. And let's see what we get. No, I didn't import pandas that time. You don't have to import it every time. So a lot of numeric columns, so that looks good. Longitude and latitude, that makes sense. Where it's located. Total number of rooms. Now, you have to make inferences when you look at data. Clearly, this is not one house, right? Let's hope not. I mean, we can use df.describe to confirm that. But it's just not looking like it. It's in median income, median house value. So the thing to predict here, I think, is commonly median house value. And, you know, the value of the house is the median. It would be like the median in a certain neighborhood, okay? Look, households, there you go, 126, so not one. Okay, so data frame looks good. Let's look at df.info to get a better sense. Shift enter. Okay, so what do we have here? Okay, this is great. The D types are almost all floats. We do have one object, and that's okay. The null count, most of them are 20,640, good number of rows. Total bedrooms does have some missing, but not that many, so this looks good. Okay, next let's look at the statistics and try to get a little interpretation in here. So that's df.describe. Okay, so what are we going to interpret? You know, latitude and longitude the statistics just aren't interesting. What's interesting is to map them, but we're not going to do that today. Do you know what I mean? Like, what's the mean longitude? It doesn't really, I mean, it does matter if you're focused on geography, but we want to just get a sense of the columns. So, like, housing median age, what do I have? Mean is 28, median 29, so that's relatively symmetric. The total rooms, 2,600 is the mean. The median is 2,100. So, you know, as to be expected, you have some larger neighborhoods pulling the mean away from the median. You expect to see similar in a lot of these columns. So, like, total bedrooms, 537 here, and 435 for median, right? And population could be different. Population mean is 1,425. I think this was the median, 1,166. Yeah. Well, let's look at one of the columns with all of them. Okay. Let's do one that we can see, like, we can see it on the left here. How about I mean, these are like neighborhoods. Let's look at population. I'm a little curious. Okay, so we have a mean of 1,400, but a standard deviation of 1,100. So what does that tell us? It tells us that 1,425 is like, that's just the mean. It's not going to be that close to it. You very well could get like 2,500 or like really low values. So you got a minimum here of 3. Okay, that's what standard deviation tells you. Remember, it tells you how far away from the mean you can expect to get. Additionally, if we look at the median here, so 1,166 is right in the middle, 787, 25 percentile at the quarter mark, and 1,725 right at the 75% mark. And then you have the min and max values as well. So 35,000 population is, you know, probably densely populated area, much larger than the median of 1,000, right? So I think it looks good. Okay, I smile because this is actually, the California housing data set actually is well known. So this is a popular data set in machine learning. It's nice. We'll probably look at it later in machine learning. because like you're clearly using like different columns, like number of bedrooms, population, etc., to get the median house value, right? So there's clearly one column, the value, the cost of the house, that the other columns can be used to predict. So I think this meets all the criteria. All right. There it is. I wasn't for sure, so I didn't say anything. It's actually stored by Google in sample data. Okay. And this MNIST is visual data, so we're not going to touch that. Okay, so hopefully that gives you some parameters around which you can use to look at the data. Okay. Do not decide these things in isolation. Discuss them with others. Discuss them with your cohort leads. Try to find your own. Try to look at some of the ones that we provide. See what jumps out at you, okay? It's not a be-all and all decision, but it's potentially a big decision because it's potentially the data set that you're going to work with for the next few weeks. So it should be something that's meaningful to you. Don't pick this one because it's like, oh, this will work. It's okay. No, find something that you're passionate about that interests you, okay? Whatever you're passionate about, look it up. Look up CSV file with it. If you're passionate about, what might one be passionate about? You could be passionate about really like anything in life, like koala bears. Is there a koala bear data set? You can look CSV straight. Data set maybe too. Look at that. I mean, 9 data sets found for koalas. There's a lot of data in the world. This is my point. So interesting stuff is out there. Look at the CSV. Just start clicking, trying things, okay? If you get a CSV file, that's what you want, okay? So have fun, explore, find data that's meaningful to you, that you feel passionate about, and I don't know, I'm just really excited to see what you guys do with it. Today's the first step, and we'll have fun up and coming when you look at all the cool things that we can do with data, all the beautiful graphs that we're going to create to bring the data to life.